All right, if you turn the paper over on the bottom of the back, there's some white space. I added this problem after I'd already printed this out. So solve using elimination. This is actually set up to solve using elimination. We could multiply the second one by 2 and then subtract, but because we have a plus and a minus y, we can just add them. And so we have 3x equals 3, so x equals 1. Plug the 1 back in to the second equation, and we get negative y equals negative 3, so y is 3. So we have the point 1, 3 as the solution. Let's do this with substitution. We should get the same answer. You have a whole bunch of choices to solve for. You got to solve for one of the variables. Pick one that has a 1 as a coefficient or negative 1. That way you don't have to divide by anything and work with fractions. So we have y equals negative 2x plus 5. Now I can replace that y in the second one with negative 2x plus 5. So we get 3x plus 5 equals negative 2. We get 3x equals 3. And again, we get x equals 1. So we have 1, 3. And of course, we have to plug the 1 back in and get the 3 again. So that's substitution. And then solve by graphing. 1, 2, 3, 4. I think I have to go up to 5. But we have y equals negative 2x plus 5. So that's a y-intercept of 5, down 1, 2, and right 1. There's 1, so there. Down 1, 2, and right 1. So we already know the answer, but this would be by graphing. Let's get the second one into slope-intercept form. So y equals x plus 2. So we go up here to 2. 1, 2, 3, 4. Oh, I did it up to 6. Here, here. So then up to, down 1, 2, and over 1. But I made a mess out of that, didn't I? Y-intercept of 5, down 2, right 1. This has a negative 2 as a slope. This has a y-intercept of 2, and up 1 over 1. There's 1, 3. Made that look easy, huh? I went up 6, and then I didn't go down 2. So anyway, graph the 2 lines, find the intersection. All right, now back to the other side. I want to show you one more time this one solved by hand. In case there's any issues, you can certainly ask. 2, 3, negative 1, 5, 1, negative 1, 1, negative 2, negative 3, 1, negative 4, 9. Swap row 1 and row 2. So we swap row 1 and 2. 1, negative 1, 1, negative 2, 2, 3, negative 1, 5, and then negative 3, 1, negative 4, 9. I like having that 1 in the top left-hand corner. You certainly don't have to. I think it makes the problem a little easier. So we have 2 times row 1 minus row 2, replace row 2. And we have 3 times row 1 plus row 3, replace row 3. All right, so I need 2, negative 2, 2, negative 4. So that makes that 0, negative 5, 3, and negative 9, right? Negative 4 minus 5. Then we have 3, negative 3, 3, negative 6, and that's going to be 0, negative 2, negative 1, 3. 1, negative 1, 1, negative 2. Well, that's 2 of the 3 zeros. Now I need that negative 2 to be 0. So 2 times row 2 minus 5 times row 3, replace row 3. 1, negative 1, 1, negative 2. So this is 0, negative 10, 6, and negative 18. And then this is 0, negative 10. I'm multiplying by 5. Negative 5, 15. And I'm subtracting. We got 0, negative 5, 3, negative 9, 0, 0, negative, positive 11, because I'm doing 6 minus negative 5. Negative 18 minus 15 is negative 33. So we have 11z is equal to negative 33. z equals 3. Negative 5y plus 3 times z, which is 3. Oh no, negative 3. I almost lost a negative. Negative 3, negative 3, negative 9. So negative 5y is equal to 0. Y equals 0. Because you would add 9 to both sides, that would give you a 0. And then at the top row, we have x plus 3, actually plus negative 3 equals negative 2. So x equals 1. So 1, 0, negative 3. Remember that y is 0, so on that last step over there, we don't have a y value as well. It's 0. I think I had one up here. Yeah, a couple. Now let's say we start out with a system of equations and we started solving it. We did all these matrices. We got down to the last matrix, and this is what we have. First of all, this would be infinite solutions, but we need now that ordered triple. Z is sitting here on the end, so we can pick anything we want for Z. Then we'd have 2y minus z equals 4. Yeah. So then 2y equals z plus 4. Y equals 1/2 z plus 2. So that's going to be 1/2 z plus 2. Now on the top line, we have x plus 2 times 1/2 z plus 2 plus z equals 3. So we have x plus z plus 4 plus z equals 3. X equals negative 2z minus 1. So negative 2z minus 1. So there's the infinite, there's the solution, infinite with that ordered triple. And then on this last one, you just have no solution. And we like those because there's no extra work involved with that one. Write as an inverse now. Write as a matrix equation. And solve using inverses. 1, negative 3, 2, 1 times xy in a vertical fashion equals negative 7, 0. There's the matrix equation. Now we're going to solve by hand using inverses. We have 1 over the determinant, which is 1 minus negative 6, which is actually 7, times. Switch the 1 and the 1. And of course, they're the same value, but we did switch those. And then make the other diagonal opposite, 3, negative 2. And then times negative 7. Oop, not a fraction. Forget I wrote that. So 1/7 times. I always save the fraction till last. Negative 7 plus 0 is negative 7. 14 plus 0 is 14. So the final answer is negative 1, 2. Negative 1, 2. Multiply. Across and down. So we got a 2 by 3 and a 3 by 2. So the columns of the first match the rows of the second. Now if they don't match, you can't multiply. The result will be a 2 by 2. So I like to set up a little template so that I know that I have everything filled in. So we have negative 2 minus 4 plus 3. Then we have negative 4 minus 1. That's across and down on each column. Then we have 0 plus 6 minus 12. And 0 plus 6 again plus 8. No, not plus 8, plus 4. Plus 4. There we go. Negative 6 plus 3, negative 3. Negative 9, negative 6, 10. Find the determinant and inverse if possible. So the determinant of this one is equal to negative 4 minus negative 12, which is 8. We cross multiply is what I call it, even though technically that's not what you do. And then we have 1/8. Switch these two, switch the -1 and the 4, and make the other ones opposite. That's the process. And we end up with -1/8, -1/4, 3/4, 1/2. The determinant of a 3x3, we need plus, minus, plus. We always start with a plus and then start alternating. Now you don't have to write all 9 of them in because you're only going to use one row. So I just need the signs for that first row. So it's like we take a +1 times 2, which is going to be 2. We cross out the row, cross out the column, and do the determinant of what's left over, which would be 0 minus 12. Then we take a -1 times a -1, that's +1 times, cross out the row, cross out the column, you get -2 minus 6. You get those, -2 minus 6. And then +1 times -3 is a -3, and you're left with finally that little matrix right there, which is 4 minus 0. We have -24 minus 8 minus 12. -32 minus 12, -44 is, that's the determinant. If you want to find the inverse on your calculator, you hit A inverse. And then if you go into the math menu, you on the very first one is change everything to fractions if the inverse has a bunch of decimals. I want fractions, not decimals. If you have any issue with getting inverses of 3x3s on your calculators, please let me know. I'd be more than happy to help you. Otherwise, we're just going to kind of skip it here. All right, the last one. The Harvest Nut Company sells create your own trail mixes where customers can choose whatever combinations they want. Colin's favorite mix contains peanuts, dried cranberries, and carob-coated pretzels. I was told that means like a fake chocolate is what carob-coated is. It sounds, the word sounds terrible, but otherwise it sounds delicious. Anyway, enough of that. The prices for each are shown below. If Colin bought a 5-pound mixture, so let's go with P plus C plus maybe Z for pretzels, because I have peanuts and pretzels, that should be a 5-pound bag. So our P's, C, and Z, they stand for poundage. And he bought it for $16.80. So 320P plus 240C plus 4Z is equal to 1680. And then after the 1680, it says that contained twice as many pounds of carob-coated pretzels as cranberries. So here's what I do. So twice as many of the pretzels. I set Z equal to the cranberries, which is C. Now that's a false statement. That is not true. That's false. So I always start with a false statement. Say Z equals C. Now that's like saying 10 equals 5 because there's twice as many pretzels. That is a false statement. And I do that on purpose. Now I think to myself, what do I do to that to make it into a true statement? And we'd have to multiply the right side by 2 to make that true. So I must have to multiply that by the C by 2. Twice as many pretzels as cranberries. Now they're evened up. Now it actually equals each other. Well, I want to turn this equation, I want to make this equation look like the other two. So we have 0P, I don't have a P, I don't have pretzels in this equation, minus 2C plus Z equals now 0 because I minus the 2C over. Well, now that one looks like the other two. Now, this will be on the calculator part of the test. I already entered this in as a 3x4. You can hear the construction. So I entered that in as a 3x4 matrix. We already did the reduced row echelon form. We got 2, 1, 2. So here's what I'll expect on the test. 2 pounds of peanuts. We have 1 pound of cranberries. And then 2 pounds of pretzels.